Okay, the last of the Mohegans for the day is the acid-base reaction. Now, acids and bases always form a salt and water when they're added together. If they're neutralized, that means they have equivalent numbers of hydrogen ions and the base ion, generally hydroxide. So in this instance, you've seen this reaction before. Sodium hydroxide plus hydrochloric acid produces table salt and water, or just regular salt water. Now, the question in this problem is an acid-base reaction. They want to know what volume of 0.1 molar hydrochloric acid, that means that it's been dissolved from the original 12 molar down to where it's 0.1 moles per liter, 0.1 moles per liter, yeah. And to neutralize 25 milliliters of 0.350 molar sodium hydroxide. Now, the first thing you got to do is find out how many milliliters you're going to have to get the equivalence of sodium hydroxide. And you do that by taking the 25 milliliters of the sodium hydroxide, which is, again, changed back to liters by dividing by 1,000. So there's 1,000 milliliters per 1 liter. And that'll give you the number of moles of hydroxide. Now you look at it like, wait a minute, what about the sodium? Well, again, the sodium and the hydroxide are both 1-to-1 in this. The OH counts as an ion, OH minus ion, and the sodium is this 1 plus. But remember, those column 1 elements, they stay in solution most of the time. So you have the hydroxide here coming out to be 8.75 times 10 to the minus third moles, which is again 0.0875 millimoles. Since we haven't covered millimoles yet, we'll let this slide. All right, since hydrogen and hydroxide are 1-to-1 when they combine together for neutrality, we need to get exactly the same number of hydroxide and hydrogen ions, HOH, H2O, same thing. That's how you get water. So the volume is equal to 8.75 times 10 to the minus third moles of hydrogen ions, correct? Got to have the same number of moles to neutralize it, divided by 0.1 moles per liter of hydrogen. That's the concentration given to you back at the start of the reaction way back up here. So you change that by dividing it out, and you come up with 8.75 times 10 to the minus second liters. And again, you got to change it to milliliters by multiplying 1,000 milliliters per liter. A lot of this is conversion stuff, and you should have learned this in 8th grade, and I realize some of you didn't, and that's the mathematical inadequacies that you'll have to overcome in this course. Your math teachers didn't do you justice, and I apologize for them, having been in this business for decades and decades at all levels. I've seen it, and it's not entirely your fault. Some of it you might have worked a little harder on the homework, but reality-wise, it's very likely an inadequate presentation or encouragement to get you into this math. But we'll try to get you through it now. Again, the volume is the 8.75 times 10 to the minus third equivalence of hydrogen. Because remember, the hydrogen and the hydroxide, I'll show you up here on the ions. The hydroxide ion and the hydrogen ion are 1-to-1. to form HOH. And that's where you get your water. So if you know one of these, and what you're trying to find is this, 25 milliliters of 0.35 molar sodium hydroxide, and all you have to do is change the milliliters to liters of the sodium hydroxide, and that'll give you the number of moles, which is 0.350 moles per liter, or 8.75 times 10 to the minus third moles of sodium hydroxide. And you got to get that same equivalent of hydrogen ions, because remember, H plus OH forms water. That means it's neutral. Since the hydrogen plus OH are identical 1-to-1, which I've said over and over again for this, the volume is arrived at by taking the 8.75 times 10 to the minus third moles of hydrogen ions, because it's got to be the same as the number of moles of sodium, divided by the concentration given in the beginning of the problem, 0.100, and that will give you the number of liters that you have, because everything else cancels out. The moles cancel out, you're left with liters. You come out with 8.75 times 10 to the minus second liters, which comes out to be 0.0875 liters. But you don't write it that way because it's awkward. So you write it 8.75 times 10 to the minus second. Then you multiply 1,000 milliliters per liter to cancel out the liters, and then you're left with milliliters, which is what you want to begin with. That's how you get all this. That's how all those steps occur. It's not inordinately complicated, but it's difficult because, again, your math has failed you along the way, and we'll try to overcome that math inadequacy as we go through these. Hopefully that gives you a start. This is stoichiometry. We're through the first section on stoichiometry. We will do more.